Okay, let's talk a little bit about solving equations when we have multiple steps to take. So hopefully you've learned how to solve equations with one step. What happens when we have multiple steps though? And again, to think about that, we just need to think about our inverse operations again. What are we going to do to undo sort of what's there already? So things like, since I'm adding 9 in this equation, I'm going to think about I'm going to have to subtract 9 at some point. Notice I'm also multiplying x by 5 over here on the left. So I'm probably going to have to divide by 5. The question is, which operation do we do first? Well, in normal PEMDAS, if I was checking my answers, right, if I was plugging in a number for x, let's say we didn't know about this 24. Let's just say we thought, hey, x was 2. Well, I would plug it in for x, and immediately we're multiplying by 5, followed by adding 9, right? If we think about regular PEMDAS, multiplying is going to come before addition. In order to solve, what we want to do is go backwards. We want to unwrap the present, right? We want to undo this. So the last thing happening is going to be the first thing to go. Since adding 9 was the last step, then subtracting 9 is a great first step. So let's go ahead. We're going to subtract 9 on both sides. I'm going to go ahead and change colors here real quick. Subtract 9 on both sides of our equation, right? Stay balanced, which basically is going to leave us with, well, 5x plus 9 minus 9 is just 5x, and 24 minus 9 would be 15. Now I'm going to follow that up. Hey, if we're still multiplying by 5, let's go ahead and divide away our 5. So I'm going to divide by 5 on this side, divide by 5 on the right side, and 5 divided by 5 cancels to a 1, 1 times x being x. And 15 divided by 5, right, is just going to be a 3. And I believe that, since x is all by itself, is a good final answer. Again, we could check our answers very quickly and go ahead and plug that back in. 5 times 3 plus 9, and see if we end up with 24, right? So we've got 15 plus 9 equals 24. Some of these numbers should be pretty recognizable. They were in blue earlier in our equation. 15 plus 9 then is 24, equal to 24, and check, that works. So again, the idea is undo the operations by doing the opposite, but we're also going to sort of undo PEMDAS, undo the order of operations. So we sort of have to back our way through the equation. So let's try a couple examples up here at the top, and then we'll talk about how to write one, such as the one down on the bottom here. So again, looking at the equation in the upper left, and feel free if you want to pause the video now, it's a great time to do so. Try these problems and see if what we end up doing here in just a second matches up with what you do on your own. But with that, let's go ahead and start. I notice that I'm multiplying by 4, right? 4 times y, and then minus 10 up here, which means the first thing to go is going to be that minus 10. I'm going to say plus 10 on both sides, right? Subtraction would have been last. So again, last thing happening, first thing to go, which leaves us with 4y on the left equal to 24 plus 10 would be 24 on the right. Then we can divide away our 4, right? Multiply by 4, divide by 4. And I'm going to divide by 4 on the other side as well. I want to do the same thing on both sides. So 4y divided by 4 becomes y, right? Times 4 divided by 4 cancels. And 24 divided by 4 would be 6. Again, you can plug that back in to check your answer. But I'm pretty sure if I put 6 in for y up here, 4 times 6 would have been 24, minus 10 is 14. Over at the right, you'll notice we have z divided by 3, and then minus 7 here, right? So again, division would have happened first, then subtraction. Last thing happening, first thing to go. I'm going to get rid of that 7. Minus 7, so I need to do the opposite. I'm going to add 7. Again, to both sides, make sure you're showing those solution steps. Negative 1 plus 7 makes 6. And z over 3, right? Minus 7 plus 7, again, is going to just cancel away. Much like, again, minus 10 plus 10, or times 4 divided by 4. Again, those items are going to cancel away. Then, to get rid of that divided by 3, we should multiply by 3. Oops, I got to change the pencil here. So I'm going to multiply by 3 on both sides. Multiply by 3 on this side. Remember that z times 3 over 3, or z times 3 over 3 times 1, those 3's again are going to cancel. And 3 times 6 would have been 18, equal to z, should be our final answer there. Okay. And again, if you take 18 and plug it in, you got to go back to the original. So now that's where that minus 7 again should still be there. 18 divided by 3, though, would have been 6, and 6 minus 7 is -1. Now, down here at the bottom, they've sort of given us a verbal phrase. So the first thing we need to do is write it out. The output of a function is 5 more than -2 times the input. Okay? Well, the output of a function is 5 more than -2 times the input. I would say that the output is equal to, right, 5 more, 5 plus, 5 more than -2 times the input. -2, and I'm going to call that input x. Right? Now, we could call the output y, but notice in the next sentence, find the input when the output is 11. I'm going to go ahead and just write in 11. If the output of the function is 5 more than -2 times the input, well then 11 is, right? 11 equals 5 more than -2 times x times the input. And with that, let's solve. I'm going to go ahead and look at what we have going. We got some multiplying and some adding. Plus 5 would be the last thing happening. Again, going to be the first thing to go. I'm not that worried about the -2 yet. Right? If I plug in for x, that's going to be the first thing happening, not the last thing. So again, this gives me 11 minus 5 would be 6, equal to 5 minus 5, it disappears, -2x. If I divide by -2, I'm going to go up here to the right. Notice on the right side, -2 over -2 just becomes x. It doesn't matter which side of the equal side we're on, so I kind of wrote the right side down there. Now it's the left. So let's go back. The left side, 6 over -2, would be -3. And again, you can plug that back into your original red equation up there and just double check and make sure you get 11 on the right side, just like you have on the left. Very last thing, let's talk one more word problem just for integrity's sake here. Brady wants to rent a booth at the local county fair to sell his PB&J on the stick. Everything at the county fair sold on a stick, right? He calls Miriam, who happens to work at the fair offices, and Miriam knows that $42 a day, right, is what it costs to rent a booth, plus a one-time fixed fee of $85, right? You got to sort of buy your spot, just reserving your spot there. Find the number of days that Brady can rent a booth if he's got $337, right, in his budget. Well, if it costs $42 per day, I'm going to say that the days, right, the number of days is going to be x. So $42 times x, right, per day, plus, remember we had to pay that one-time fee, that fixed fee we call it, a one-time thing, $85, and we only have $337, right? So we're going to set that equal to 337. And let's figure out what x would need to be to come out as close as possible to 337. Now, we could do an inequality, but I'm thinking we should be able to get away with just an equation here. Let's subtract our 85. Minus 85 leaves us with 42x on the left. And 337 minus 85. Well, I know 330 minus 80 would be 250. So I'm thinking we're $252 right now. You can check that on the calculator if you want to. Since we're multiplying by 42, I'm going to divide away 42. And that leaves us with just x, just the number of days. And 252 divided by 42, I believe, is 6. So 6 days would be the time we could rent. If you have any questions about solving equations or need any help with those types of problems, talk to your teacher. Otherwise, have a great day.